Hello, my name is Gnanesh from Mandava, and this is my first ever YouTube video on my computer vision class proposal of face detection. So before starting into my project proposal, I would like to say some things about computer vision. Computer vision is a concept that was first created to give the abilities to the computer camera about what human eye can do and actually interpret from the data it sees. So you can already guess by now that computer vision is a subset of artificial intelligence and machine learning, in which computer devices can interpret and understand the vision of the human eye. So, for example, without the computer vision or the camera or any of the boxes, we can observe that we can easily interpret that it's a person or it's a car or it's a traffic light or anything else. But these days, like computer vision cameras can be given the ability to detect the person or a handbag or a traffic light in the image. So it has like many applications in the field in many fields like retail, automotive, healthcare, agriculture, banking, industrial, and like countless applications. First, computer vision in retail. Computer vision helps retailers in many ways like management, payments, data collection, and compliance. For example, you can see this image of a retail manager surveilling his store um, about what people are doing and who the person is and how they are behaving. And for example, in the field of automotive, um, computer vision can help see the car or other cars, and it also helps in the self-driving technology, like the companies like Tesla, in which the car can drive by itself without the help of any driver, and it also keeps the people safe by following all the rules and keeps you secure. For example, in the agriculture, like in if you see this image, the leaves are having black dots. Usually, like people can't analyze each and every plant uh, by and it includes a lot of manpower to analyze each and every plant and like see what plant is not growing. So like the use of computer vision, the analysis of multiple plants can be sent to the farmers' devices, like what plants are not functioning normally, and then what plants' health and growth is affecting, and how is its productivity, and it's keep tracks of it. And and moving forward, like computer vision has like multiple and countless applications in all the fields. So my project is on facial detection, like detection the face in a given image. Locating one or more faces in a given image or video is a key issue. The use of advanced filtering procedure to distinguish locations that represent the face and filter them with accurate classifiers. This is a step done because the face cannot be recognized without even being detected. Hence, it should detect all the various different kinds of faces by detecting including the different kinds of facial structures and hairstyles for different ages. The detection of the face is given in a given image or video is normally done during the following steps. So, like many methods that can detect the face in a given image or video. One of them is called feature based. In a feature based, first the original image is taken, and then a filter called Gabor filter is taken, in which it highlights the contours of the image, and it is analyzed with 2D Gaussian. For example, this is a black and white picture, and it's an old picture, so the 2D Gaussian provides like a really black and white um, image, in which these two images are combined for the highlights, and then the peaks are generated. So these white things you see, these are actually called peaks, in which the center of the core, which is actually more whiter, or you can say more it has like higher coefficients than the this part, or like part in the middle, or like the borders. So the highest peak points or coefficients are marked as you see in the image E, and then it keeps track of the key features of the face and detects a face. So moving forward to the knowledge-based approach is more likely to detect the face like humans. It follows the same rules of humans as humans. It introduces multi-resolution focus of approach. So the face knowledge-based usually follows the rules we follow to detect a human face. Like, okay, so in a given image, a person has like ears, eyes, mouth, and a chin. So we recognize it as a face. So the knowledge based, you can it can also detect an image in a low resolution by looking at histogram and searching for eyes, nose, or other features of the face. And moving forward to the appearance based. The appearance based method depends on a set of delegate training face image defined of face models. The appearance-based approach is better than other ways of performance. In general, appearance-based methods rely on techniques from statistical analysis and machine learning to find relevant characteristics of face images. This method also uses feature extraction for face recognition. The appearance-based model is further divided into submethods for the use of face detection, which are as follows. Eigenface-based. Eigenface-based algorithm used for face recognition and its method for efficiently representing faces using principal component. And then, using the principal component analysis, the image is converted into a matrix, which is in the form of numbers. So it generates eigenvalues and vectors for developing the PCA. The mean is calculated and is subtracted from the original image, and principal components are calculated, which helps in detecting the face. In the distribution phase, the algorithms of PC and Fisher's discriminant can be used to define the subspace representing the facial patterns. There is a trained classifier which correctly identifies the instance of a target pattern class from a background image patterns. Given it works, many detection problems like object detection, face detection, emotion detection, and face recognition have faced successfully by neural networks. As you can see, the image is trained to the multiple layers for its maximum accuracy and like higher recognition or detecting a face, and then the output for the given output image or video, the the image is selected and then it is compared to the previously trained images, in which it gives a good output in detecting the face. Support vector machine. Support vector machine are linear classifiers that maximize margin between the decision, hyperplane, and the examples of training set. First applied uh, in identifying the face. Sparse network of nodes. They define a sparse network of two linear target of nodes, one representing the face patterns and other the non-face patterns. It is less time-consuming and efficient. Naive-Bayes classifiers. The compu- they computed the probability of a face to be present in the picture by counting the frequency of occurrence of series of patterns over the training images. The classifier captured joint statistics of local appearance and position of the faces. And moving forward to the working of the conventional form of uh, facial detection. There are many techniques to detect the faces. With the help of these techniques, we can identify the faces with higher accuracy. The techniques have almost same procedure for face detection such as OpenCV, neural network, MATLAB, etc. The face detection work has to detect multiple faces in an image. Here we work on OpenCV for face detection. There are some of steps how face detection operates, which are as follows. First, the image is imported by providing the location of the image. Like this image is imported from by providing the location, and then the color image, which is in RGB, is converted as a grayscale, which is easy to detect the faces. After that, the image manipulation is used, in which the resizing, cropping, blurring, and sharpening of the images is done. The next step is image segmentation, which is used for contour detection, the sequence of multiple of a single image or trans, so that the classifier can quickly detect the objects or the faces in the picture. The next step is the use of horror-like features. These are like the horror-like features are detected in a frame of images. All human faces share some universal properties like the eyes or the cheekbones or like the forehead, and these are detected using edge features, line features, and central surround features. Like the eye region is darkening than the neighbor pixels, and the nose region is brighter than the eyes region. The Horlike algorithm is also used for feature selection or feature extraction for an object in an image. With the help of edge detection, line detection, center detection, and detecting eyes, nose, mouth, etc. in a picture, it is used to select the essential features of an image and extract these features of the face detection. The next step, like after everything of the image segmentation is done, is to give the coordinates x, y, w, and h, in which creates a box, a rectangular box in which the picture to show the location of the face is made. After this, there are so many detection techniques that are used for detection such as smile, etc. And moving on to the interactivity, you can complete the quiz, and here are the references. This reference mainly, the first reference mainly explains about the technical features without using the machine learning and artificial intelligence algorithms. The second one usually creates the computer vision and its modern trends. And the third one is made for the neural networks and non-neural networks references. Thank you.